As we want to look at QEC and understand some of the basic concepts, a couple of important concepts are the fact that QEC leverages what we call logical qubits. Um, these are uh, these are sort of abstract encoded qubits that are comprised of multiple physical qubits. Um, and our logical operations similarly operate on logical qubits, which are these composite objects that we're creating with the encoding. Uh, you can think about a lot of the operations as really being analogous to the non-encoded forms. We can create superpositions. We can execute gates on logical qubits, but the underlying operations do involve multiple, operations on the individual qubits. So here I've shown a very simple 3-qubit repetition code, but I want to point out that many of the error-correcting codes are much more complex and involve many more physical qubits. For example, the Shor code here is a 9-qubit code. This is not the simplest form, but you can start to see this is a lot more complicated. And in fact, in some architectures, researchers are proposing codes that have hundreds of thousands of qubits, physical qubits in the code. So this does get very complex, but the degree of redundancy that you're adding to the state really gives you a greater capability to correct errors. So the redundancy aspect is something that is similar or analogous to classical error correction.